Welcome to Crisis in Perception, where we examine the systems shaping our world.
You know, all the way back in 1972, a study called The Limits to Growth came out, and it dropped a bombshell about our future. Today, we're going to unpack its core logic to really understand the deep structures that might be driving our world towards some very predictable crises. So that message, simple, powerful, was also, well, really controversial. And to get why, we've got to break down the logic behind it. We'll start by identifying the system itself. Then we'll look at its incentives, its predictable outcomes, why it's so darn hard to change, and finally, how it's all connected. All right, first things first, we have to get a really clear picture of the system we're actually talking about here. Think about the world after World War II. This incredible explosion of growth happened, and out of it came this system that basically sees endless economic and population growth as normal. It's the engine that has powered our modern world. And it's built on one massive assumption, that there are no hard limits. None. Okay, so we've got the engine, but what's the fuel it runs on? Well, that's all about incentives. And what happens when a system's core incentives are pointing it, well, in completely the wrong direction? It's actually pretty simple when you break it down. The system's logic consistently rewards stuff like short-term economic gains while completely ignoring or, discounting the long-term environmental costs. It's a classic case of what gets measured gets managed. And right now, we're measuring today's profits, not tomorrow's stability. Okay, here's a great way to think about it. Imagine you're in a sealed greenhouse, right? And you have a thermostat. We just keep cranking up the heat because it feels good right now. But here's the catch. The thermostat only measures the temperature. It has absolutely no idea that the glass itself is about to shatter from the pressure. And this right here is the classic tragedy of the commons in action. Even when everyone can see the shared resource, in this case, the entire planet, is being damaged, it's still in each individual's short-term self-interest to just take a little bit more. So you take a growth-obsessed system, you give it these flawed incentives, and then you let it run loose in the real world. What happens? Well, the outcomes are actually pretty predictable. With a simple linear system, if you push twice as hard, you get twice the result. Simple, right? But our global systems, they're not like that at all. They're non-linear. That means you can push and push and push and see almost no effect until, bam, you suddenly hit a tipping point and everything changes at once. This diagram here, this shows the engine of the computer model, and it's all about feedback loops. Some of these loops reinforce growth, creating this powerful snowball effect. For example, more industrial output creates more capital, which then gets reinvested to create even more output. Talk about a powerful growth engine, right? So the big question is, what happens when you just let these feedback loops run free in the computer model? Well, way back in 1972, this is the picture it painted. Not some nice, gentle slowdown, but a rapid overshoot, where we use up resources way, way faster than the Earth can possibly replenish them. And what comes after an overshoot isn't a soft landing, it's a sudden, uncontrolled collapse. So the really crucial thing to get here is that collapse isn't some random, out-of-the-blue event. It's actually a baked-in, predictable outcome of the system's own logic. When you combine that relentless exponential growth with real-world limits and, this is the most important part, delayed feedback, where you don't feel the consequences until it's way too late, well, this is the result you get. Okay, so if the logic is this clear, it raises a huge question. Why hasn't anything been done? Well, this gets into the persistence of the system's core beliefs. The warnings in the report were often just dismissed out of hand, and not because the science was bad, but because the conclusion was just too scary, too unsettling. It flew in the face of all that post-war optimism. It's the classic Cassandra effect, right? We have this deep psychological tendency to just ignore the person who brings us the bad news. So this inability to really wrap our heads around the consequences of things like delayed feedback and exponential growth, that's not just a simple disagreement over policy. It is a fundamental crisis in perception. We're acting as if the world is linear and simple, when the reality is that it's complex and nonlinear. And that massive disconnect is what prevents us from seeing the cliff we're all running towards. And it's not just in our heads. Our core institutions are structurally hooked on this idea of continuous growth. Politicians needed to get reelected. Financial markets literally needed to keep the whole system of debt stable. And the media reports it constantly as the main sign of how well we're all doing. This whole setup makes it incredibly difficult to even talk about changing course, let alone actually do it.
All right, finally, let's zoom all the way out. Because this growth system doesn't exist in a vacuum. It's deeply, deeply interconnected with pretty much every other major global system.
And all these systems just reinforce each other, creating a powerful lock-in. The demand for energy fuels industrial growth. That growth is then expanded through global trade. And the whole thing is financed by a monetary system that's literally based on the promise that tomorrow will always be bigger and richer than today. It's a really tightly woven fabric, which makes the entire structure even more resistant to any kind of change.
Crisis in Perception examines how systems shape belief and how better tools help us see clearly. This project is free and publicly accessible. If you'd like to support the time, tools, and research behind Crisis in Perception, you can become a supporter on Patreon. For a longer audio-based analysis of this topic, see the deep dive linked in the description. If you enjoy this kind of systems-level analysis, please like, subscribe, and comment with books or topics you'd like us to explore next.